Hi students, today we are going to discuss some more problems in our textbook in laws of motion. See the page number 36, see the eighth one. Three identical blocks, each of mass 10 kg, are pulled as shown on the horizontal frictionless surface. If the tension in the rope is 30 newtons, that means F is given. What is the acceleration of each block and what are the tensions in the other ropes? Now here, neglect the mass of the ropes. Three blocks are arranged on a surface like this with the help of two strings. This is the one of the string and this is the another string. Now you can apply the force. How much here? You can apply the force 30 newtons. Blocks having mass is how much? Each having mass 10 kg. In this case, we have to find acceleration of the system as well as the tensions in the strings. Here tension is given as T1. Here tension is given as T2. Let us force is applied on this direction. Therefore, acceleration of the system is in this direction. Let us assume. Now we want to write the free body diagrams. Free body diagram for this 10 kg block. FBD for 10 kg block. 10 kg block. This is the position 1 and this is the position 2. This is the position 3. Let us say 10 kg block in the position 1. What are the forces acting on the block? Let us see free body diagram. This is a 10 kg block on right side. On right side, T1 acts. On left side, there is no force. Right side, T1, left side, no force. Acceleration in this direction. From this, acceleration is in this direction. That's why this force is more. Net force means T1 minus 0 is equal to 10A MA. Take the free body diagram for 10 kg at the position 2 or otherwise at the position A, at the position B, at the position C. Here A is a position B. 10 kg block is here. 10 kg block is here. What are the forces acting on the block? Right side T2, left side T1. T2, T1. Acceleration on which side? Right side. What is the net force? Which one is more here? T2. T2 minus T1. T2 minus T1 is equal to 10A MA. Now you take a free body diagram for FBD for 10 kg. What are the forces acting on this 10 kg which is placed at the position C? Now take a 10 kg body. This is the 10 kg body. Right side force 30 newtons. Left side force T2. Acceleration right side. Net force 30 minus T2 or T2 minus 30. What we will write? We'll write 30 minus T2 net force. Acceleration is in this direction. That's why 30 minus T2 is equal to 10A. 10 kg block. 10A. Now we can add these equations. We can add these equations. T1 gets cancelled. T1 minus T1, T2 minus T2. On the left side 30, on the right side what is the value? 30A. From this A is equal to 30 by 30. How much? 1 meter per second square is the acceleration of the system. Now you have to find tensions. From this equation, T1 is equal to how much? T1 is equal to 10A. 10 into A means 1, that is equal to 10 newtons. How to find T2? From this equation, what is the T2 value? We have 30 minus T2 is equal to 10A. From this, T2 is equal to 30 minus 10A. That is equal to 30 minus 10 into A means 1. 30 minus 10, which is equal to how much? 20 newtons. These are the acceleration of the system as well as tension in the strings. Now we take see the 11th problem. See the 11th problem. A vehicle has a mass 1500 kg. Mass of the vehicle is given as 1500 kg. What must be the force between vehicle and road if the vehicle is to be stopped with a negative acceleration of here acceleration is given as a negative acceleration. To stop the vehicle we can apply negative acceleration. Here we have to find what must be the force between vehicle and the road. That means force is equal to, we have the formula m into a. What is the mass here? 1500. A minus 1.7, which is equal to 2250 2550 newtons. Here what is the minus sign indicates? The minus sign indicates we can apply the force on a body. The minus sign indicates the direction of force is opposite. Next, see the 12th problem. A truck is moving under a hopper with a constant speed of 20 meter per second. Truck is moving with constant speed of 20 meter per second. Sand falls on the truck at the rate of 20 kg per second. 20 kg per second. That means dm by dt. Truck is moving like this. Sand is falling like this. At the rate of dm by dt, this is the velocity of the truck. V. Now, what force acting on the truck due to falling of sand? You can move the truck with the same velocity. You can apply force. What is the force acting on the truck due to falling of sand? We have to find force required. According to Newton's second law, F is equal to dp by dt, rate of change of momentum. F is equal to d by dt of P means mv. Here V is constant. The truck is moving with same velocity. V take outside V into dm by dt. From this, what is the V value? 20. What is the dm by dt value? 20. 20 into 20, how much? 400 newtons. Next, see the 13th problem. Two ice skaters initially at rest push off each other. If one skater whose mass is 60 kg, what is the mass of the first skater? 60 kg. Mass of the moving with the velocity push. One skater whose mass is 60 kg has a velocity. What is the velocity? 2 meter per second. What is the velocity of the other skater? How to find? Whose mass is given as how much? 40 kg. Two ice skaters initially at rest. Initially at rest means their momentum is zero. According to law of conservation of momentum, according to law of conservation of momentum, if there is no external force acting on the system, total momentum of the system remains constant. Initially they are at rest, that's why their momentum is zero. Now after pushing one with each other, then their momentum is given as first skater momentum m1v1, second skater momentum m2v2. Total momentum of the system means two skaters m1v1 plus m2v2. From this, m2v2 is equal to minus m1v1. From this, v2 is equal to how much? Minus m1v1 by m2 minus m1. What is the m1 value? 60. What is the v1 value? 2 by what is the m2 value? 40 minus 120 by 40, which is equal to minus 3 meter per second. Minus sign means they are in their velocities are in opposite direction. Next, 14th one. Correct the answer as 3. See the 14th one. A ball of mass m moves perpendicularly to a wall with a speed v. Ball of mass m moves perpendicularly to a wall with a speed v. This is a ball moving with a velocity v means momentum of the ball in this direction is mv. Strikes it and rebounds with the same speed. Rebounds with the same speed. That means the same momentum. The ball strikes the wall perpendicularly with a momentum mv and rebounds with the same momentum. Same velocity means here same momentum. Mass into velocity. Now, what is the direction of magnitude of average force acting on the ball due to the wall? Here we have to find average force acting on the ball due to the wall. Force acting on the ball we have to find. What is the initial momentum of the ball? What is the final momentum of the ball? What is the initial momentum? mv. What is the final momentum? mv. What is the change in momentum? mv minus mv, 0. You don't say like that. Why? Because momentum is a vector quantity. You can subtract vectorially, not algebraically. Momentum is a vector quantity. Let us see here carefully. What is the initial momentum of the ball? Magnitude mv and direction which is in the right side direction, that is a positive x-axis direction. That's why I cap magnitude into unit vector gives that vector. That is the initial momentum vector. What is the final momentum vector? Final momentum vector means Pf bar. What is its magnitude? mv. What is its direction? Along negative x-axis. That's why here we'll put minus I cap. What is the change in momentum? Do you know force is equal to change final momentum minus initial momentum by time. Change in momentum by time according to Newton's second law. Here F bar is equal to what is the final momentum? Minus mv I cap minus mv I cap final momentum minus what is the initial momentum? mv I cap by time. F bar is equal to minus mv I cap minus mv I cap minus 2 mv I cap by t. This is the force vector or force acting on the ball. Here it will be written as minus 2 mv by t 2 mv by t into minus I cap. This is the magnitude. What is the magnitude of force here? F is equal to 2 mv by t. That is the magnitude. In which direction the force act? Clearly minus I cap. Minus I cap means minus I cap away from the wall. This towards the wall plus I cap. Away from the wall minus I cap. Clearly minus I cap indicates the force acting on the ball. Force acting on ball is away from wall. Away from wall. Minus sign indicates this one. Minus I cap. Okay. These are the some problems in our textbook, and also see the example problem in our textbook. Page number 33, example 5. Page number 33, example 5. A cannon of mass 1200 kg located on a smooth horizontal platform fires a shell of mass 300 kg in a horizontal direction with a velocity 400 meter per second. Find the velocity of the cannon after shoot. After it is shoot. Let us say this is the cannon. Cannon mass is m1. Let us say. Now this is the bullet. Whose mass is, let us say, m2. Cannon fires a bullet with what velocity? It fires the bullet with a velocity given 400 meter per second. This is the case as that of a bullet fired from a gun. Here, initially, this is the cannon, this is the bullet. Bullet and cannon system is initially at rest. That means momentum is zero. According to law of conservation of momentum, what is the total momentum before firing? Zero. Bullet at rest, cannon at rest, both velocities is zero. That's why their momentums are zero. After firing, what is the total momentum of the bullet? Total momentum of the bullet as well as momentum of the gun. Momentum of the bullet is, let us say, m1 v1. Momentum of the cannon or gun is M2 V2. From this, what is the formula you can use? M2 V2 is equal to minus M1 V1. Did you understand clearly? According to law of conservation of momentum, total momentum before firing is equal to total momentum after firing. What is the total momentum before firing? 0. Both bullet as well as cannon are at rest. After firing, bullet moves. Cannon also some moves with some velocity. Let us say V2. From this, V2 is equal to minus M1 V1 by M2. V2 is equal to, what is the M1 value? M1 value. Mass of the cannon is given as 12,000 kg. 12,000 kg. Here, mass of the bullet is given as 300 kg. Therefore, M1 means 12,000. V1 means how much? Here, you have to find V1 only. Here, you have to find V1. 1 represents for cannon, 2 represents for bullet. V1 is equal to minus M2 V2 by M1. V1 is the velocity of the cannon. V1 is equal to minus, what is the M2? M2 is given as 300. What is the velocity of the bullet? 400 by, what is the mass of the gun? 12,000. That is 3 zeros gets cancelled, which is equal to 10 meter per second. Therefore, the answer velocity of the gun is here 10 meter per second. Minus sign indicates while the bullet moves in the forward direction, gun or cannon recoils in the backward direction. That is the minus sign indication. Let us see one of the other problem here. Suppose here two blocks are present. One is 5 kg and other one is 10 kg. Here you can apply the force on this side 20 Newton. On this side 40 Newtons. Let us say on this side 10 Newtons. What is the, here you can apply the forces. This is a string. What is the acceleration of the system as well as tension in the strings? Let us see some problem here. Let us say acceleration of the system is in this direction and tension in the string, let us say T. Now we can apply free body diagrams. For 10 kg block, what are the forces acting on the block? For 10 kg. Right side force 40, left side force T. Acceleration is in this direction, that's why net force means 40 minus T is equal to 10A. For 5 kg block, for 5 kg block, on this side T minus 10. T minus 10 is equal to 5A. Now you can add these two. TT gets cancelled. 40 minus 10, 30 is equal to 15A. A is equal to how much? 30 by 15, which is equal to 2 meter per second square. That is the acceleration of the system. And you have to find tension in the string. You can take one of the equation. 40 minus 10 T is equal to 10A. 40 minus T is equal to 10 into, what is the acceleration? 2. 40 minus T is equal to 20. T is equal to how much? 40 minus 20. T T is equal to 20 newtons. These are the some problems in our textbook. All of you practice the problems and thoroughly read the theory and see the theory questions in our material. And all of you do the in material there is a exercise is there how to do the problems for practice. Okay, all of you first of all read theory and then you will do problems. Okay, thank you. These are the your textbook problems. Okay, thank you.